place where you are sitting right now has already vanished. Not metaphorically, physically. The ground beneath you is rotating eastward at tremendous speed, carrying you across the surface of Earth, while the planet itself travels through space around the Sun. The coordinate you occupied a moment ago is no longer beneath your feet. It has already slipped behind you. Yet nothing feels like motion. The room is still. The floor is steady. The air seems quiet and unmoving. But that calm stability hides something deeply strange. You have never been in the same place twice. The unsettling part is not the speed. It is the illusion of stillness. Your senses were built for surfaces, not for planetary motion. They detect the vibration of footsteps, the shift of balance, the pull of gravity under your feet. But when an entire world moves together, every mountain, ocean, atmosphere and body participates in the same motion. Nothing inside the system feels the movement of the system. So the ground appears stable, the room appears fixed, your location feels permanent. But permanence is the mistake. The coordinate you imagine as a place is only a temporary alignment between several moving systems. Earth rotates, the planet travels around the Sun, and the Sun itself drifts through the galaxy. The place you believe you occupy exists only for an instant before the larger machinery carries it away. The floor beneath you appears to hold a single promise. Stay where you are, and the world will stay with you. A chair remains where it was placed. A table remains where it stood yesterday. Walls keep their shape and their position. The surface of the planet feels like a platform that quietly supports everything above it. The idea seems obvious. The ground is the most stable thing you know. But stability on Earth is not the absence of motion. It is shared motion. Imagine looking down at the planet from far above the atmosphere. Continents, oceans, clouds and cities are all attached to the same rotating sphere. Every mountain, every forest, every street, every person is carried together as the planet turns. You do not slide across the surface because the surface carries you. Earth completes one full rotation every day. That turning is slow enough to feel invisible from the ground, but its scale hides enormous speed. At the equator, the surface of the planet sweeps eastward at roughly 1,600 kilometers each hour. Cities near the equator move fastest, while regions closer to the poles travel along smaller circles. But everywhere on Earth, the ground is part of a rotating system. The room around you is not stationary. It is being carried. Every building on the planet participates in this rotation. The oceans rotate, the atmosphere rotates, even the air inside your lungs rotates with the planet. Nothing remains behind. You are not standing on a fixed surface. You are standing on a turning sphere. Yet none of this motion feels like motion. Your body senses acceleration, not steady travel. When a car suddenly speeds up, you feel the push into your seat. When an airplane banks, you feel the shift in gravity across the cabin. But if every object around you shares the same movement, the motion disappears into the background. Stillness becomes an agreement. Everything near you moves together, so nothing appears to move at all. What you call a place is simply a patch of rotating ground that happens to be carrying you at this moment. The moment before now, that patch was slightly west of here. A moment from now, it will be slightly east. The ground beneath you is not waiting. It is passing. The rotation of Earth quietly erases the idea of a fixed coordinate. Every second, the planet turns a little farther, carrying cities and oceans through a new position in space. The coordinate you occupied a minute ago has already rotated away from you. The place you believe you are in is already gone. But rotation is only the first layer of motion. Because while the planet turns beneath your feet, the entire world is also travelling somewhere else. Rotation gives the first hint that the ground beneath you is not stable. but rotation alone would only carry you in circles. If Earth simply spun in place, every point on the surface would return to the same position in space once every day. The path would close, the coordinates would repeat. But the planet does not rotate in empty stillness. It is also moving around the sun. Step outside at night and look toward the stars. The constellations appear fixed above the horizon. Night after night, they seem to occupy the same arrangement in the sky, like distant markers that quietly surround the planet. But those stars are not standing still while Earth spins beneath them. The entire planet is travelling around the sun along a vast orbital path. Earth completes this journey once each year. The orbit stretches across nearly 1 billion kilometres of space, forming a wide elliptical loop around the central star of our system. To complete that path in a single year, Earth moves with enormous speed. The planet travels around the sun at roughly 100,000 kilometres each hour. That means that during the time it takes to listen to a single sentence of this narration, Earth has already moved several dozen kilometres through space. You are not only rotating, you are also orbiting. But again, nothing feels different. The oceans remain level, the air remains calm, buildings remain steady against the ground. The motion of Earth through space produces no wind across the surface because the entire atmosphere travels with the planet. The planet carries its air, its water, its mountains, and every living creature along the same trajectory. Once again, motion becomes invisible. The room around you is now travelling through space at tremendous speed, but every object inside the room shares the same motion. Your chair, your desk, the walls around you, and the ground beneath the building all follow the same orbital path around the sun. Shared motion hides the journey. From your perspective, the sun rises and sets while the ground remains fixed. But the deeper geometry tells a different story. At this moment, the rotating Earth is also advancing along its orbit. The planet moves forward through space while spinning beneath you. These two motions combine. The rotation of Earth turns you eastward across the surface, while the orbital motion carries the entire planet forward through space. If you could trace your path through the solar system, it would not form a circle. It would stretch into a long, curved ribbon through space, a continuous forward path that never closes behind you. The place you occupied yesterday does not exist along that path anymore. Earth has already moved millions of kilometres away from it. Return to the exact spot on the floor where you began listening to this episode, and it may feel like the same place. The walls are the same. The air is the same. The ground beneath you appears unchanged. But in space, the planet is now somewhere else entirely. You did not come back to the same location. The solar system carried you forward. The surface of Earth only gives the illusion of return because the rotation of the planet brings the same ground beneath you again, but the ground itself has been transported along the orbital path around the sun. A circle on the planet becomes a spiral in space. Each day the planet turns once. Each day the entire world also moves farther along its orbit. The path behind you is not a ring, it is a widening helix traced through the darkness of the solar system. And even this description quietly hides another layer. Because the sun itself is not standing still while the planets orbit around it, the star at the centre of our system is also moving. The sun feels like the centre of everything you know. Every planet circles it, every orbit in the solar system curves around its gravity. Light and warmth spread outward from it, shaping the climate of worlds and the chemistry of atmospheres. From the perspective of Earth, the sun appears almost immovable. It rises, crosses the sky and sets with dependable rhythm. Year after year its position against the distant stars shifts slowly with the seasons, but the star itself seems to anchor the solar system in place. But the sun is not an anchor. It is a traveller. Far beyond the outermost planets, beyond the thin halo of icy debris surrounding the solar system, the Sun continues moving through a much larger structure. That structure is the Milky Way galaxy. The Milky Way is not a scattered field of stars. It is a vast rotating system containing hundreds of billions of suns, along with enormous clouds of gas, dark matter, and dust. These components form a flattened disk that slowly turns around a hidden center deep within the galaxy. The Sun is one small member of this rotating disk. Our star sits in one of the spiral regions of the galaxy, far from the crowded center. From here, the solar system quietly circles the galactic core along an enormous orbit that takes roughly 230 million years to complete. During that time, the Sun carries every planet with it. Mercury travels with the Sun, Venus travels with the Sun, Earth travels with the Sun. Even the distant icy worlds far beyond Neptune remain gravitationally bound to the same moving star. The entire solar system is drifting through the galaxy together, and the speed is extraordinary. The Sun moves around the centre of the Milky Way at roughly 800,000 kilometres each hour. At that pace, the solar system crosses distances that dwarf the scale of planetary orbits. Yet once again, the motion disappears from everyday experience. The galaxy does not rush past your window. The stars in the night sky appear fixed in place because they are travelling with us inside the same rotating structure. Just as cities move together across the rotating surface of Earth, stars move together within the rotating disk of the galaxy. Shared motion hides the journey again. When you look at the night sky, you are not seeing stationary lights scattered across space. You are looking outward from inside a rotating stellar current. The Sun carries you through that current every second. Earth rotates beneath your feet. The planet orbits the Sun, and the Sun itself sweeps through the Milky Way as part of a vast galactic rotation. These motions stack on top of one another. Your path through space is no longer a spiral around the Sun. It becomes a longer and more complex trajectory woven into the motion of the galaxy itself. Imagine a small bead travelling along a thread, while the thread is pulled through a moving river. The bead traces a path shaped not only by its own motion, but by the larger current that carries the thread. The solar system is that bead. The Milky Way is the current. The Sun does not hold the planets in a quiet orbit inside a fixed universe. It carries them forward through a rotating galaxy filled with billions of other moving systems. The sky appears calm only because the motion is shared by everything you see. But the illusion of stillness continues to dissolve. Because the galaxy that carries the Sun is not a stationary structure either. It too is moving. To understand the next layer of motion, imagine tracing the path of Earth through space over the course of a year. From the ground, the motion appears simple. The planet circles the Sun and returns to roughly the same position each year. The orbit seems like a closed loop, a familiar ring around a stable star. But this picture quietly assumes that the Sun itself is standing still. It is not. While Earth moves around the Sun is travelling through the Milky Way. The star pulls the entire solar system forward along its galactic path, while the planets continue their smaller orbital motions around it. These two motions combine into something unexpected. The orbit of Earth does not form a circle in space. It forms a long, drifting spiral. Imagine watching the solar system from a distant vantage point somewhere above the galaxy. The Sun moves forward through the galactic disk like a glowing vessel crossing a dark ocean of stars. Behind it trails a faint pattern of curved paths, the tracks of the planets spiraling around the moving star. Each planet follows the Sun. Mercury traces tight coils near the star. Jupiter drifts along wider arcs. Neptune sweeps across enormous loops that take more than a century to complete. Earth moves somewhere between them, circling the Sun while the entire system advances through the galaxy. The path never closes. Each orbit occurs in a new region of space because the Sun has already travelled farther along its galactic route. Even if Earth completes a perfect circle around the Sun, the center of that circle has moved millions of kilometers during the same time. The geometry transforms. A closed orbit becomes a forward-moving helix stretching through the Milky Way. Your planet is not circling in place. It is threading through space. If you could draw the path of Earth over thousands of years, you would see a long, braided ribbon winding through the galaxy. Each yearly loop wraps around the Sun, while the Sun itself continues drifting along the vast arc of its galactic orbit. The solar system behaves less like a set of circles and more like a migrating swarm. And you are inside it. Every second, your planet follows the Sun through this enormous trajectory. The continents, oceans, and atmosphere all participate in the same motion, carried together by gravity and inertia. Stillness remains an illusion created by shared motion. The chair beneath you moves with Earth. Earth moves with the Sun. The Sun moves through the galaxy. Every layer carries the next. What you call your location is actually the intersection of several simultaneous journeys. A rotating planet, an orbiting world, and a migrating star all overlap to produce the temporary coordinate where you now exist. The coordinate dissolves almost instantly. The ground rotates away from it. The orbit advances beyond it. The galaxy carries the solar system farther along its path. The place you believed you occupied survives for only a brief alignment of motions. Then the alignment breaks. And yet the scale of motion does not stop with the movement of a single star inside the Milky Way, because the galaxy itself is not resting in the darkness of space. It is travelling too. From inside the Milky Way, the galaxy appears like a distant background. On clear nights, the faint band of starlight stretches across the sky like a pale river of dust and light. For most observers, it feels less like a structure and more like scenery, a quiet backdrop surrounding the solar system. But the Milky Way is not a backdrop. It is the system carrying everything you know. The galaxy spans more than 100,000 light-years across. Within that enormous disk, hundreds of billions of stars orbit a massive gravitational center, hidden behind clouds of dust and radiation. Our Sun is only one of those stars. It sits far from the crowded core, roughly halfway between the center of the galaxy and the outer edge of the disk. From this distant position, the solar system travels along a broad, circular route around the galactic center, completing one full journey roughly every 230 million years. Long before dinosaurs walked the surface of Earth, the Sun occupied a different region of the galaxy. The star has been traveling ever since. This means the solar system is not merely orbiting the Sun while drifting through space. It is part of a much larger rotating system that contains billions of other moving stars. The galaxy itself is a vast gravitational engine. Stars flow around the galactic center in enormous arcs, forming the spiral structure visible in distant images of other galaxies. Gas clouds drift between these stars, collapsing into new suns. Ancient stellar remnants sweep silently through the disk. Invisible dark matter surrounds the galaxy in a massive halo that extends far beyond the visible spiral arms. All of these components move together. The Milky Way rotates slowly, carrying its stars along enormous galactic paths. Our Sun is simply one passenger within that rotating stellar ocean. From this perspective, the solar system becomes something different. It is no longer the central stage of motion. It is a small subsystem embedded inside a far larger structure. The Sun moves through the galaxy like a single glowing bead inside an immense rotating wheel of stars. Earth moves with it. The rotation of Earth beneath your feet is one layer of motion. The orbit of the planet around the Sun is another. The galactic orbit of the Sun adds a much larger layer that stretches across hundreds of millions of years. These layers stack together into a single continuous trajectory. Your life unfolds along that path. Every conversation you have ever had, every step you have taken across the surface of the planet, every moment of history recorded in human memory, has occurred while the solar system quietly migrated through the Milky Way. Civilizations rise and fall while the sun advances along its galactic route. The place you imagine as home is not a fixed address in the universe. It is a moving coordinate inside a rotating galaxy. And the galaxy itself exists inside an even larger environment. Because the Milky Way does not travel through empty space. It moves among other galaxies. The Milky Way often appears in diagrams as a solitary island of stars. A bright spiral floating alone in darkness, surrounded by empty space that stretches in every direction. From this perspective, the galaxy feels like a complete world, a vast rotating structure that contains everything important within its disk. But the Milky Way is not alone. It lives inside a small gravitational neighborhood. Surrounding our galaxy are dozens of smaller companions, faint dwarf galaxies that drift through the same region of space. Some are little more than loose clouds of stars. Others are elongated streams of stellar debris, slowly pulled apart by gravity. All of them are moving. They orbit the Milky Way the way moons orbit a planet. Their paths stretch across hundreds of thousands of light years as they circle the larger galaxy, sometimes passing through the outer halo before drifting outward again. The Milky Way itself dominates this region of space, but it is not the only major galaxy here. There is another. Far beyond the outer edge of our galactic disk, across more than 2 million light-years of space, another spiral galaxy approaches slowly through the darkness. It is called Andromeda. Seen from Earth, Andromeda appears as a faint oval of light in the night sky. It looks small and distant, barely visible without optical aid. But that faint smudge contains roughly 1 trillion stars. It is slightly larger than the Milky Way, and it is moving toward us. The two galaxies drift through space under their mutual gravity, slowly closing the distance between them. Over billions of years, their paths will eventually intersect, their spiral arms stretching and distorting as their gravitational fields interact. Stars will scatter across enormous arcs. Gas clouds will collapse into bursts of new star formation. The two galaxies will gradually merge into a single, larger system. But that encounter lies far in the future. For now, both galaxies are members of a loose collection known as the Local Group. The Local Group contains more than 50 galaxies, though most of them are small dwarfs orbiting the two large spirals. Gravity binds the entire collection together, holding the galaxies within a shared gravitational basin that stretches across roughly 10 million light-years. This means the Milky Way is not simply rotating in isolation. It is drifting within a cluster of galaxies. Every star in the Milky Way participates in this larger motion. The Sun carries the solar system through the galaxy, while the galaxy itself moves through the Local Group along a slow gravitational dance with Andromeda and the surrounding dwarf systems. Once again, the pattern repeats. Smaller systems move within larger systems. Planets circle stars. Stars orbit galactic centers. Galaxies drift within gravitational groups. And every layer carries the one below it. The motion you experience on Earth is nested inside all of these movements. Your position on the surface of the planet is influenced not only by Earth's rotation or its orbit around the Sun, but also by the galactic journey of the Sun and the slow gravitational migration of the Milky Way among its neighbouring galaxies. The idea of a fixed cosmic location becomes harder to defend. Your address is not Earth alone. It is Earth inside a solar system, inside a galaxy, inside a moving group of galaxies drifting through a larger structure. And even this group is not standing still. The Local Group itself is falling towards something far larger. If you could step far outside the Local Group and watch it from a distance, the motion would not look like a calm cluster of galaxies drifting gently through space. It would look like descent. The galaxies of the local group are not floating randomly through the universe. Their paths bend slowly in a particular direction, drawn by gravity toward a region of space that contains an enormous concentration of mass. This region lies far beyond the local group. It is located in the general direction of a massive galaxy cluster called Virgo. The Virgo cluster sits roughly 50 million light-years away and contains thousands of galaxies bound together by their combined gravity. The mass of this cluster distorts the surrounding geometry of space, creating a gravitational basin that nearby galaxies slowly fall toward. The local group is one of those travelers. The Milky Way, Andromeda, and their smaller companions drift through space, while gradually descending toward this larger gravitational structure. But Virgo is not the final destination. Astronomers studying the motion of thousands of galaxies discovered that even the Virgo cluster itself appears to be moving. Entire groups and clusters of galaxies flow in roughly the same direction, across enormous distances of space. These motions reveal the presence of something even larger. A vast gravitational region, sometimes referred to as the Great Attractor. This name does not describe a single object, like a star or a galaxy. Instead, it refers to an immense gravitational concentration hidden behind dense clouds of dust within the plane of the Milky Way. Because this region lies along the crowded band of our own galaxy, direct observation is difficult. But the motion of galaxies reveals its influence. Across hundreds of millions of light-years, galaxies appear to drift along similar paths toward this enormous gravitational basin. Clusters, groups, and individual galaxies all participate in this large-scale flow. The local group is carried along with them. The Milky Way does not simply rotate in place while its stars orbit quietly within the disk. The entire galaxy moves through intergalactic space, gradually descending toward this larger gravitational structure. Picture a mountain range hidden beneath a layer of fog. You cannot see the peaks directly, but you can watch rivers flowing down the slopes. The direction of those rivers reveals the shape of the land beneath the fog. Galaxies behave like those rivers. Their motion reveals the gravitational landscape of the universe. The local group is not wandering through empty space. It is sliding along the slopes of a vast gravitational terrain shaped by enormous concentrations of matter. This realization quietly replaces another map. Earlier, you may have imagined galaxies as isolated islands drifting through an endless void, but their motion reveals that they are connected through invisible gravitational currents. Clusters pull on groups, groups pull on individual galaxies. Entire regions of the universe slowly migrate along these enormous gravitational gradients. The Milky Way is part of that current. And so are you. Every second, the solar system moves through the galaxy. The galaxy moves within the local group. The local group flows toward a massive gravitational basin hundreds of millions of light-years away. The journey never pauses. But this gravitational descent is only one piece of a larger architecture. Because when astronomers began mapping the positions and motions of galaxies across vast distances, they discovered that these flows are not random. They follow a hidden structure that spans the entire universe. When astronomers began mapping the positions of galaxies across enormous distances, the first maps appeared chaotic. Galaxies seemed scattered through space like grains of dust floating in darkness. Each galaxy rotated and drifted under its own gravity. Clusters formed where gravity pulled many galaxies together. Between them stretched long regions that appeared almost empty. At first, the universe looked disorganized. But as the maps improved, a different pattern slowly emerged. Galaxies were not distributed randomly. They formed enormous interconnected structures. Instead of floating alone, galaxies gathered along vast strands that stretched across hundreds of millions of light-years. These strands connected to massive clusters where thousands of galaxies crowded together. Between the strands lay enormous empty regions where very few galaxies existed. The universe began to resemble something unexpected. A web. Astronomers now call this structure the cosmic web. It is the largest known architecture in the universe. Vast filaments of galaxies stretch through space like luminous threads. At the intersections of these filaments, enormous clusters form dense nodes containing thousands of galaxies. Between them lie vast voids where gravity has pulled matter away over billions of years. From a sufficient distance, the universe begins to look less like scattered islands and more like a living structure. Matter gathers along the threads. Galaxies move along the filaments. Clusters form where those filaments intersect. The local group occupies one tiny portion of this web. Our galaxy sits along one of these enormous cosmic strands, embedded within a much larger filament that stretches across millions of light years. The gravitational currents that guide the motion of galaxies follow the same structure. Clusters pull on nearby galaxies along the filaments. Groups drift slowly along these same gravitational pathways. The descent toward larger structures, like the motion toward the Virgo cluster and beyond, is not random wandering. It is guided flow. The Milky Way is not simply falling toward one massive region of gravity. It is travelling along a gravitational corridor formed by the cosmic web itself. Picture a network of rivers spreading across a continent. Water flows through narrow channels that merge into larger rivers before eventually reaching the sea. Galaxies move in a similar way. Small systems drift along narrow gravitational filaments. Those filaments feed larger clusters, where gravity becomes stronger. Over billions of years, galaxies slowly migrate through this vast network of cosmic currents. The motion of the Milky Way through the universe follows one of these currents. The solar system travels with the Sun through the galaxy. The galaxy drifts with the local group along the slope of a massive gravitational basin, and that basin itself lies along a filament within the cosmic web. Your path through space is now part of something far larger than planetary motion or galactic orbit. It is embedded within the architecture of the universe itself. But this web of galaxies does not sit quietly in space. Even the web is changing, because the fabric of space itself is stretching. The cosmic web might appear permanent. Enormous filaments of galaxies stretch across unimaginable distances, connecting clusters into a network that spans the observable universe. From the largest perspective available to astronomy, this structure resembles a frozen architecture. Vast threads of matter suspended in darkness, holding their shape across billions of light years. But the web is not fixed. It is slowly changing. The space between galaxies is expanding. This expansion does not behave like motion through space. Galaxies are not simply flying away from one another through a pre-existing void. Instead, the fabric of space itself stretches, increasing the distance between objects embedded within it. Every filament of the cosmic web participates in this stretching. Clusters slowly drift apart. Voids grow larger. The entire network gradually expands like a vast, three-dimensional lattice, slowly being pulled outward in every direction. This expansion began billions of years ago. After the early formation of galaxies and clusters, the universe continued to stretch. Over immense timescales, this expansion gradually separated structures from one another. Galaxies that were once closer together drifted farther apart as the underlying geometry of space expanded. The cosmic web did not vanish. It simply spread outward. Within each filament, gravity still pulls matter inward. Galaxies continue migrating along the strands toward dense clusters where the gravitational pull is strongest. Local structures remain connected by these flows, but the larger universe around them keeps expanding. Imagine a web drawn across the surface of a balloon. As the balloon slowly inflates, the strands of the web stretch apart from one another, even though the threads themselves remain connected. The cosmic web behaves in a similar way. Galaxies move along gravitational currents inside the filaments, while the larger structure of space gradually expands beneath them. This creates a quiet tension between two forces. Gravity pulls matter together. Cosmic expansion pulls space apart. Clusters continue forming where gravity dominates. Filaments feed those clusters with a slow stream of galaxies drifting along gravitational slopes. Yet the distances between entire superclusters slowly increase as the universe expands. The Milky Way participates in both of these motions. Locally, our galaxy remains bound within the local group. The Milky Way and Andromeda will eventually merge because their mutual gravity is strong enough to overcome the expansion of space between them. But beyond this local neighborhood, the universe is stretching. Distant galaxies drift farther away over billions of years, carried by the expanding fabric of space itself. This means the path you are traveling through the universe is not simply shaped by gravity and orbital motion. It is also shaped by the growth of space. Earth rotates beneath your feet. The planet orbits the sun. The sun travels through the galaxy. The galaxy drifts along a filament of the cosmic web, and the web itself slowly expands within the growing universe. Every layer carries the next. Your position in space is not only moving, the stage on which that motion occurs is changing as well. And this realization quietly introduces another unsettling idea. If space itself is expanding, then the coordinates you imagine as fixed points in the universe cannot remain fixed for long. Even the map of the cosmos is slowly stretching beneath you. The expansion of space quietly removes another certainty. Distance itself becomes unstable. From the ground on Earth, distance feels simple. Two objects stand a few meters apart. A mountain lies many kilometers away. A distant city sits somewhere beyond the horizon. These separations appear fixed. But once the scale widens to the universe, distance stops behaving like a rigid measurement between objects. Instead, it begins to behave like a property of space itself. And space is stretching. Galaxies that lie beyond the gravitational grip of our local region are slowly carried away as the universe expands. The farther a galaxy is from us, the faster this expansion increases the distance between us and that galaxy. This effect becomes visible in the light that reaches Earth. Light travelling from distant galaxies arrives slightly stretched. Its wavelength has been lengthened during the long journey across expanding space. Astronomers call this redshift because the light shifts toward the red end of the spectrum as the universe expands. The stretching of light is the signature of a stretching universe. But this phenomenon reveals something deeper. When light begins its journey across the cosmos, the galaxy that emitted it occupies a particular coordinate in space. By the time that light finally arrives at Earth, billions of years later, the universe has expanded dramatically. The galaxy that produced the light is no longer where it was. In fact, in many cases, the galaxy has moved billions of light years farther away during the time its light was travelling toward us. You never see distant galaxies as they are now. You see where they were when the light began its journey. The sky itself becomes a record of vanished coordinates. Every star, every galaxy, every faint smudge of distant light represents a moment in the past. The farther away an object lies, the older the light that reveals it. The night sky is not a map of the present universe. It is a layered archive of ancient positions. Even the sun you see shining overhead is slightly delayed, its light taking several minutes to reach Earth. The sun you see is already in the past compared with the sun that exists at this exact moment. For distant galaxies, the delay becomes immense. Some of the faintest galaxies visible in deep astronomical images emitted their light more than 10 billion years ago. Those galaxies may have changed shape, collided with neighbours, or drifted far across space since that light first began its journey. The coordinate you observe is only a historical trace. This realization quietly alters the meaning of the universe around you. When you look outward into space, you are not observing a frozen arrangement of objects that all exist in the same moment. You are looking across time. The deeper your gaze travels into the universe, the farther back in time your view becomes. Each distant galaxy reveals a different era in the long evolution of cosmic structure. The cosmic web itself is seen at many different ages, depending on how far away its galaxies lie. The universe becomes a layered history written in light. And this means that the path you are traveling through space is not only a journey across distance, it is also a journey through time. The place you occupied a moment ago no longer exists in space. And the universe you see around you does not exist entirely in the present either. At this point, the idea of a place has quietly begun to dissolve. First, the ground beneath you began to move. Earth rotated, carrying every mountain and city through new positions in space. Then the planet itself travelled around the sun, turning a circle into a drifting spiral. The sun migrated through the Milky Way, pulling the entire solar system along a vast galactic route. The galaxy joined a larger motion inside the local group. The local group descended through gravitational slopes toward distant clusters. And all of this motion unfolded inside a cosmic web that slowly stretches as the universe expands. Every layer replaced the one before it. What once looked like a stable surface became a moving planet. The planet became a passenger of a star. The star became a traveller inside a galaxy. The galaxy became a node within a much larger gravitational network. But another realization now emerges from this layered motion. All of these movements are happening at the same time. Your position in the universe is not defined by one trajectory. It is defined by the combination of many trajectories stacked together. Earth spins beneath your feet once each day. The planet sweeps around the sun once each year. The sun circles the galactic center over hundreds of millions of years. The galaxy drifts through the local group over billions of years. These motions overlap like transparent currents flowing through the same point in space. You exist where they intersect. Imagine dropping a small leaf into a river that flows into a larger river, which eventually reaches the ocean. The leaf does not follow one simple path. It moves with the small current, the larger river, and the slow movement of the sea. Its trajectory becomes the result of all of them combined. You are that leaf. The coordinate you call here is only the temporary intersection of these layered cosmic currents. Earth carries you through rotation. The orbit of the planet advances you along the solar system path. The sun transports that entire system through the Milky Way. The galaxy moves along gravitational filaments inside the cosmic web, and the expanding universe stretches the distances between everything beyond our local region. Every moment adds a new segment to that trajectory. Your life unfolds along a path through the universe that no one has ever travelled before. Not even you. The location you occupied a second ago has already vanished beneath layers of motion. The ground rotated away from it. The orbit advanced beyond it. The galaxy carried the solar system further along its path. Even the expanding universe stretched the background geometry of space while all of this occurred. There is no fixed coordinate waiting for you to return. The universe does not store locations. It stores motion. The idea of a stable place belongs to the scale of human experience, where the movements of planets and galaxies remain invisible. But once those motions become visible, the map changes. What you thought was a location becomes a trajectory. And the trajectory continues far beyond the galaxy itself. When astronomers first began mapping the universe on its largest scales, the goal seemed straightforward. Find where the galaxies are. Telescopes scanned the sky, recording the positions of millions of distant systems. Each galaxy became a point on a growing map, a small marker placed somewhere in the expanding cosmos. The early expectation was simple. Once enough points were recorded, the structure of the universe would appear clearly. But the first complete maps produced an unsettling pattern. Galaxies were not scattered evenly. They gathered along immense threads and sheets that stretched across enormous distances, leaving behind vast, empty regions where almost nothing existed. These empty regions grew so large that entire clusters of galaxies could fit inside them with room to spare. The universe had texture. Imagine standing inside a gigantic cavernous structure made not of stone, but of matter itself. Walls of galaxies extend across millions of light years, forming immense surfaces where gravity has gathered material together. Between those walls lie voids so enormous that a beam of light could travel for tens of millions of years without encountering a single galaxy. This is the architecture of the cosmic web. Our galaxy occupies a narrow strand within this network. The local group drifts along one of these filaments while gravity slowly pulls it toward denser intersections where clusters of galaxies accumulate. But the web is not static. Galaxies flow along its strands like water through branching rivers. Small groups move toward larger clusters. Filaments feed those clusters over billions of years. Matter gradually migrates along the structure toward regions where gravity becomes strongest. Seen from a sufficiently distant vantage point, the motion becomes clear. Galaxies are not wandering through empty space. They are traveling along predetermined corridors shaped by gravity. The cosmic web behaves like a giant transportation network across the universe. And the Milky Way is already on one of its routes. Our galaxy moves along a filament that stretches toward larger structures far beyond the local group. Gravity gently guides this motion, pulling galaxies along the same invisible slopes that shape the web itself. The journey is slow, unfolding across billions of years. But the direction is not random. The Milky Way is drifting along a path carved into the universe by the distribution of matter on the largest scales. The solar system rides inside this motion. Earth rides inside the solar system. You ride on Earth. Every second of your life takes place inside a galaxy that is following one of these immense gravitational corridors through the cosmic web. The idea of wandering through a featureless universe no longer holds. The universe has roads, and your galaxy is already traveling along one of them. But this architecture raises a deeper question. If galaxies move along the filaments of the cosmic web, what created the web itself? To understand where the cosmic web came from, the story must move far backward in time. Long before galaxies formed, before stars ignited, before planets existed, the universe looked nothing like the structure we see today. It was nearly uniform. Matter filled space as a hot, expanding plasma. Light could not travel freely because particles scattered it in every direction. The universe was dense, bright, and almost perfectly smooth. But not completely smooth. Tiny irregularities existed within that early distribution of matter. Slight regions of higher density and slightly emptier regions nearby. These differences were incredibly small, fluctuations measured in fractions of a percent. Yet those tiny variations became the blueprint for everything that followed. Gravity amplifies imbalance. Where matter becomes slightly denser, gravity pulls additional material toward it. That additional matter increases the density further, strengthening the gravitational pull. Over time, this process builds structure from almost nothing. The early universe contained billions of these tiny gravitational seeds. As the universe expanded and cooled, matter began slowly flowing toward those slightly denser regions. Over millions of years, the densest pockets collapsed into the first halos of dark matter, enormous invisible structures that gathered ordinary matter into their gravitational wells. Inside those halos, the first galaxies began to form. Gas cooled and condensed, the first stars ignited. Galaxies assembled within these invisible gravitational scaffolds, built largely from dark matter. But the pattern of those halos was not random. The earliest fluctuations in the universe were stretched and organized by cosmic expansion into long connected structures. Dark matter collapsed along these lines first, forming the skeleton of what would later become the cosmic web. Galaxies formed along the same structure. Matter collected into filaments where gravitational collapse was strongest, leaving behind enormous regions where material drained away. Those regions gradually became the great cosmic voids. The web emerged naturally from the early conditions of the universe. Small density variations grew into filaments. Filaments connected into sheets and clusters. Clusters formed massive nodes that continue pulling matter inward today. The universe built its own architecture. The cosmic web is not a late arrangement of galaxies. It is the matured shape of tiny irregularities that existed when the universe was still young. Everything you have followed so far emerges from those early fluctuations. The motion of galaxies along filaments, the descent of clusters toward gravitational basins, the slow gathering of matter into dense intersections of the web. All of it traces back to faint patterns imprinted in the universe billions of years ago. Those patterns shape the structure through which your galaxy now travels. The Milky Way moves along a path that was quietly determined long before Earth existed, long before the Sun formed, long before the atoms in your body were assembled inside ancient stars. Your current location in the universe is part of a trajectory that began when the universe itself was young. But the structure built from those early fluctuations does not remain unchanged forever. Because the expansion of the universe is slowly altering the future of that web. For billions of years, gravity shaped the cosmic web. Matter gathered along its filaments. Galaxies drifted slowly toward dense clusters. Enormous structures formed where the strands of the web intersected, creating the largest gravitational systems in the universe. But the universe contains another influence that grows stronger with time. The expansion of space is accelerating. For much of cosmic history, gravity slowed the expansion that began at the birth of the universe. The pull of matter resisted the outward motion, gently reducing the rate at which galaxies drifted apart. But something changed. Roughly 5 billion years ago, the expansion began to speed up again. Astronomers discovered that distant galaxies were not only moving away from us, they were accelerating outward faster than expected. Some unknown property of space itself was pushing the universe apart. This phenomenon is now called dark energy. Unlike gravity, which pulls matter together, dark energy acts as a kind of expansive pressure embedded in the fabric of space. As the universe grows larger, this effect becomes stronger because more space exists in which it can operate. The result is a slow but relentless stretching of the cosmos. Clusters of galaxies remain bound together because their gravity is strong enough to resist the expansion locally. Filaments of the cosmic web continue feeding matter toward those clusters. But the distances between entire superclusters steadily increase. Over billions of years, this expansion will reshape the visible universe. Galaxies that are not gravitationally bound to our local region will gradually slip beyond our observable horizon. Their light will stretch and fade until they disappear entirely from view. The cosmic web will slowly fragment. Each gravitationally bound region will become its own isolated island of galaxies, surrounded by an expanding ocean of empty space. The local group will eventually merge into a single large galaxy, formed from the collision of the Milky Way and Andromeda. That merged system will remain bound together by gravity, even as the rest of the universe expands away. But distant galaxies will vanish. Future observers living trillions of years from now may look outward into the sky and see only their own local galaxy, surrounded by darkness. The larger cosmic web that once connected countless galaxies across the universe will have stretched so far apart that its distant structures will no longer be visible. The architecture of the universe will fade from view. This future isolation reveals something quietly remarkable about the present moment. You are living during an era when the cosmic web is still visible. The expansion of the universe has not yet erased the large-scale structure that connects galaxies across immense distances. Astronomers can still map the filaments, measure the flows of galaxies, and trace the gravitational currents that shape the universe. The map is still readable, but it will not remain readable forever. The universe is gradually stretching the web apart, and the path you are travelling through space exists only within this temporary era of cosmic visibility. Now return, briefly, to the room where you began. A chair, a floor, walls standing quietly around you. Perhaps a window where daylight or darkness rests against the glass. Nothing in this environment appears to be travelling through the universe. The scene feels anchored, but the map that once supported that feeling has slowly been replaced. First, the floor began to move with the rotation of Earth. Then the planet carried you around the Sun along a yearly arc. The Sun transported the entire solar system through the Milky Way. The galaxy drifted with the local group through intergalactic space. The local group descended along a filament of the cosmic web, and the web itself expands within the growing universe. Each layer widened the frame. What once looked like a stable location became a moving coordinate embedded inside larger systems of motion. The ground beneath you was never an anchor, it was simply the smallest vehicle in a long chain of transport. But there is another consequence hidden in this layered motion. None of these systems return to exactly the same arrangement. Earth completes a rotation each day, but the planet has advanced along its orbit. The orbit closes around the Sun, but the Sun has moved farther along its galactic path. The galaxy continues its drift through the local group. The local group continues descending through the cosmic web. The paths never overlap perfectly. Every rotation of Earth occurs in a new region of space. Every orbit of the planet forms another loop in the long spiral traced through the galaxy. Each galactic orbit unfolds in a universe whose expansion slowly changes the distances between cosmic structures. Return to the same room tomorrow, and the walls will appear unchanged. The same floor will support your weight. The same objects will remain where you left them. The same horizon will greet the rising sun. But the universe will not be the same. The planet will occupy a different region of its orbit. The solar system will have travelled farther through the galaxy. The galaxy itself will have moved slightly along the gravitational currents of the cosmic web. The coordinate where you sit tonight will never exist again. Not because the room has changed, because the universe has moved. And so your life unfolds along a path that no other moment in cosmic history has followed. A continuous trajectory through rotating planets, orbiting stars, migrating galaxies, and expanding space. You do not remain in places. You pass through them. And every place you have ever known was only a brief alignment of moving systems before the universe carried it away. Consider the path your body has followed since the beginning of this episode. While these words have unfolded, Earth has rotated beneath you, carrying your city several hundred kilometers eastward across the surface of the planet. At the same time, the planet has advanced tens of thousands of kilometers along its orbit around the Sun. The Sun itself has moved millions of kilometers through the Milky Way during the same interval. And the galaxy has shifted slightly within the local group, while drifting along the gravitational slope of the cosmic web. All of these motions occurred while you remained seated in the same room. The illusion of stability survives only because every nearby object participates in the same motion. The chair, the walls, the air, the ground beneath the building, and the entire planet move together as one system. Shared motion hides the journey. But if you imagine the path of a single atom in your body across the span of your lifetime, the scale becomes almost impossible to picture. From the moment you were born, Earth began rotating you through thousands of cycles of day and night. The planet carried you along its yearly orbit again and again, while the Sun quietly advanced through the Milky Way. Over decades, the solar system has moved billions of kilometers through the galaxy. Your life has traced a long ribbon through space. Each breath you have taken occurred at a different coordinate along that ribbon. Every memory you hold belongs to a point on that path, a moment when countless layers of cosmic motion intersected to create the place you experienced. The universe does not pause to preserve those intersections. They dissolve immediately as the systems continue moving. This means that the place where you heard the first sentence of this episode is already unreachable. The planet rotated away from it. The orbit advanced beyond it. The galaxy carried the solar system farther along the galactic path. The coordinate vanished almost as soon as it existed. And this pattern continues without interruption. Earth rotates again tomorrow. The orbit continues around the Sun. The solar system drifts through the Milky Way while the galaxy moves along the filaments of the cosmic web. You will never step into the same cosmic coordinate again. What feels like returning home is actually the reappearance of familiar surroundings carried into a new region of space. The room returns. The coordinate does not. Your life unfolds as a moving intersection of cosmic systems. A rotating planet, an orbiting world, a migrating star, a drifting galaxy, a universe that continues expanding while all of these motions unfold. Stillness was never part of the design. You have been traveling the entire time, and the journey continues far beyond the horizon of the galaxy itself. At this scale, something subtle begins to change in the meaning of motion. Until now, the journey has sounded like travel through a landscape, planets moving through space, stars migrating through galaxies, galaxies drifting through the cosmic web. But space is not a fixed landscape through which objects pass. Space itself is part of the motion. When the universe expands, galaxies are not simply flying away like debris scattered through an empty void. The distances between them increase because the fabric of space stretches between them. Imagine points drawn on the surface of a sheet of rubber. If the sheet is slowly pulled outward in every direction, the points move farther apart, even though none of them slide across the surface itself. The distance grows because the surface grows. The universe behaves in a similar way. Galaxies move through space under gravity, but at the largest scales, the expansion of space quietly increases the distance between regions that are not gravitationally bound together. The stage stretches while the actors move. This changes how the map of the universe must be imagined. Earlier, it was tempting to think of your journey as a long path across a stable background of stars and galaxies. But that background is not fixed. The cosmic web slowly expands while its galaxies continue migrating along gravitational filaments. The coordinate system itself evolves. A point in the universe cannot remain permanent if the fabric that defines distance continues to stretch. Your trajectory through the cosmos is therefore shaped by two simultaneous transformations. Local motions guide your path through planets, stars, and galaxies. Cosmic expansion reshapes the geometry of the space that surrounds those motions. The result is not a single line through space. It is a path through an expanding structure. Imagine a thread being pulled through a piece of cloth, while the cloth itself is slowly stretching. The thread forms a path, but the fabric around it changes shape at the same time. Your life unfolds along a similar thread. Earth rotates beneath you while the solar system migrates through the galaxy. The galaxy moves within the local group while the cosmic web stretches across the expanding universe. Each layer adds motion. Each layer changes the geometry of the map. And because the map itself evolves, the idea of returning to a cosmic coordinate becomes even less meaningful. There is no permanent grid waiting in the background of the universe. The grid is changing. The place you imagined as a location in space was never a point on a fixed map. It was a moment within a moving and expanding structure. And that structure continues to widen around you. Imagine pausing the universe for a moment. not stopping the motion of planets or galaxies, but freezing the entire cosmic structure in place so that every position becomes fixed. In that frozen instant, a map of the universe would appear possible. Galaxies would occupy defined coordinates. Filaments of the cosmic web would hold their shape across enormous distances. Clusters would sit at the intersections like bright knots in a giant lattice. But the universe never pauses. The filaments continue feeding galaxies toward dense clusters. Gravity slowly rearranges matter across the web. And at the same time, the expansion of space stretches the entire structure outward. The map is always changing while you are inside it. This means that the trajectory you follow through the cosmos does not cross a static landscape. It moves through a structure that is constantly evolving while you travel within it. Galaxies that are visible tonight were once closer together. Billions of years ago, the cosmic web was denser and more compact. Filaments were shorter, voids were smaller. Clusters had not yet gathered as much matter as they do today. The universe has been unfolding this architecture gradually. Over time, the web becomes more pronounced as gravity gathers matter along its strands. At the same time, cosmic expansion stretches the entire structure outward, widening the spaces between the largest systems. Your galaxy participates in both processes. The Milky Way drifts along one of the filaments, while gravity draws nearby systems together inside the local group. But beyond that local region, the expansion of space slowly carries distant galaxies farther away. Two different futures are unfolding at once. Locally, gravity will merge galaxies together. The Milky Way and Andromeda will eventually combine into a single enormous galaxy. Smaller companion galaxies will join them over time, pulled inward by the same gravitational pull. But beyond that merged system, the rest of the universe will gradually fade from view. Galaxies outside our local gravitational neighborhood will move so far away that their light will no longer reach us. The expanding universe will stretch their light until it becomes too faint to detect. Future observers living inside the merged galaxy may look outward and see almost nothing beyond their own stellar system. The cosmic web will still exist, but it will lie beyond the observable horizon. In that distant era, the universe will appear far smaller than it does today, not because its structure vanished, but because its expansion carried distant regions beyond visibility. You are living during a rare window of cosmic history, a time when the large-scale structure of the universe can still be observed. Astronomers today can trace the filaments of the cosmic web, measure the flows of galaxies, and reconstruct the gravitational currents shaping the cosmos. These maps reveal the pathways along which galaxies travel across billions of years. The Milky Way occupies one of those pathways right now. Your planet moves within that galaxy. Your body moves with the planet. And all of this motion unfolds during a brief era when the architecture of the universe is still visible from inside it. The map exists only temporarily, but the journey continues whether the map can be seen or not. The longer the journey continues, the more the meaning of distance begins to change. From the perspective of a human lifetime, the motions you have followed so far seem enormous. A planet turning through space, a star sweeping around a galactic center, a galaxy drifting along filaments that stretch across millions of light years. But the universe measures time differently. Galaxies require billions of years to complete their slow migrations along the cosmic web. Entire clusters evolve across spans of time so vast that the rise and fall of civilizations pass unnoticed within them. The trajectory you are following through space extends far beyond the scale of a human life, even beyond the lifespan of Earth itself. 4 billion years from now, the Milky Way and Andromeda will collide. Their spiral arms will stretch and distort as gravity pulls their stars into new orbits. Over hundreds of millions of years, the two galaxies will merge into a single massive system. The solar system may survive that encounter, carried along by the motion of the sun as the galactic structure reshapes itself around it. But by that time, the Sun itself will be approaching the end of its life. Its outer layers will expand, transforming the star into a red giant, large enough to engulf the inner planets. Earth will not remain the world it is today. The oceans will vanish. The atmosphere will escape into space. The planet that carried you through this journey will eventually become unrecognizable. Yet the larger motions will continue. The merged galaxy formed from the Milky Way and Andromeda will remain bound together by gravity, while the rest of the universe continues expanding away from it. Distant galaxies will fade beyond the observable horizon as the cosmic web stretches apart. Over trillions of years, the night sky will grow darker. The paths of planets and stars will continue inside the local galaxy, but the wider architecture of the universe will slowly disappear from view. The filaments of the cosmic web will still exist somewhere beyond the horizon, but their light will no longer reach observers inside the merged galaxy. The map will be gone, but the motion will remain. Even in that distant future, every star inside the merged galaxy will continue orbiting its center. Planetary systems will still rotate around their stars. Galaxies will still follow gravitational currents within the larger structure of the universe. The journey never ends. The coordinates only continue changing. The place you occupy tonight exists only within this brief moment of cosmic history. The planet still circles the sun. The sun still moves through the Milky Way. The galaxy still travels along the filaments of the cosmic web. The universe is still wide enough for its structure to be seen. But every second that passes moves you farther along that path, and farther away from the coordinates that once existed behind you. Now return again to the quiet scene where this began. A room that appears stable, a floor that feels solid beneath your feet, walls that seem to hold their position in the world. Nothing in that scene suggests a journey across the universe. But the map has changed. The floor beneath you is not a fixed platform. It is a moving surface carried by the rotation of Earth. The planet itself is not anchored in space. It travels around the sun along a continuous path through the solar system. The sun is not stationary either. It moves through the Milky Way, carrying every planet with it through a slow galactic migration. The galaxy drifts with the local group along a filament of the cosmic web, while the universe itself expands around these structures. Each layer replaced the idea of a stable place. The room remained. The coordinate vanished. Return tomorrow, and the chair may still be there. The walls may appear unchanged. The ground will support you, just as it did before. But the location you occupy will be entirely new. Earth will have rotated through another cycle. The planet will have moved farther along its orbit. The solar system will have advanced through the galaxy. The galaxy itself will have shifted slightly within the cosmic web. Every system continues moving. Every coordinate dissolves. The universe does not provide fixed positions that endure across time. It offers only trajectories, paths traced by objects carried within larger motions. Your life unfolds along one of those paths. Each moment becomes a point along a moving thread, woven through rotating planets, migrating stars, drifting galaxies, and expanding space. The place you believed you occupied at the beginning of this episode is already gone. Not destroyed, simply carried away. And the same quiet truth will apply to every place you experience for the rest of your life. You will visit many locations, but you will never stand in the same place twice. There is a quiet consequence hidden inside everything you have just followed. If every place dissolves into motion, then the idea of being located somewhere in the universe becomes strangely fragile. We are taught to think of location as an address, a city on Earth, a planet in a solar system, a star inside a galaxy. These layers appear like nested boxes that define where we exist. But the deeper map reveals something different. None of those boxes remained fixed long enough to define a permanent coordinate. Your city rotates across the surface of Earth. Earth advances along its orbit around the Sun. The Sun travels through the Milky Way. The galaxy drifts through the local group. The local group descends along filaments of the cosmic web, while the universe itself stretches. Each layer carries the one beneath it. The coordinate you call here exists only as long as these motions temporarily align. Then the alignment disappears. Imagine placing a small dot on the surface of a turning wheel that is itself rolling across a floor, while the entire room drifts slowly across a moving ship. Where is the dot? The answer changes every moment. Your position in the universe behaves the same way. You are not located at a fixed point within a cosmic grid. You are part of a moving intersection between many different systems, each traveling through its own larger environment. The planet carries you. The star carries the planet. The galaxy carries the star. The cosmic web carries the galaxy. Every layer moves. Stillness was only the agreement between nearby objects moving together. Break that agreement by widening the frame, and the motion becomes visible again. What once felt like a place becomes a passage. This realization does not make your surroundings less real. The chair beneath you still supports your weight. The ground still holds your steps. The horizon still marks the boundary of what you can see. But these familiar surfaces are part of a larger vehicle. Earth is not simply a world. It is a moving platform crossing the universe. And every second it carries you into a region of space that no human has ever occupied before. Imagine marking a point in the air beside you. Not on the floor, not attached to the walls, just a small invisible coordinate suspended in the space next to your body. For a moment it seems like a harmless idea, a simple reference point that could remain where it is while you move around it. But the universe does not allow that coordinate to remain. Earth rotates, and the air surrounding you rotates with it. The atmosphere is carried along with the turning planet, sweeping that imagined point eastward across the surface of the world. Within minutes, the coordinate has already travelled many kilometres relative to the distant stars. But the rotation of Earth is only the first motion acting on it. The planet continues advancing along its orbit around the Sun, transporting that point of air tens of thousands of kilometres through the solar system every hour. The coordinate moves, even though nothing touched it. Then the Sun carries the entire solar system through the Milky Way. The galaxy itself drifts along the gravitational filaments of the cosmic web. The coordinate is swept along by every one of these motions. There is nowhere it can remain. Even the emptiness of space cannot hold a position still when the structures containing that space continue moving through larger environments. What you imagined as a fixed point dissolves into a moving participant in the same cosmic journey. This reveals something strange about the way humans think about location. We often imagine that space contains stable coordinates waiting for objects to pass through them, like markers placed across a vast grid. A planet moves from one coordinate to another, while the coordinates themselves remain untouched. But the deeper structure of the universe does not behave like a grid. The coordinates move with the systems that define them. Points on Earth move with the rotating planet. Positions within the solar system move with the orbit of the Sun through the galaxy. Galactic coordinates drift with the motion of the Milky Way inside the local group. Even the cosmic web slowly stretches as the universe expands. Every reference frame participates in motion. A location only exists relative to the system that carries it. Remove the system, and the coordinate loses its meaning. This is why the idea of returning to the same place in the universe becomes impossible at the largest scales. You can return to the same street. You can stand again in the same room. You can sit in the same chair. But those objects are not located where they once were. They have been transported by every layer of motion that surrounds them. The entire environment moved together. Shared motion created the illusion that the place remained the same. But from the perspective of the wider universe, that location has already drifted away. The place you imagine as here is only the current intersection of moving systems. A rotating planet, an orbiting world, a migrating star, a drifting galaxy, a universe that continues expanding around all of them. And every second that intersection shifts again, carrying you quietly into a new coordinate that has never existed before. For most of human history, this motion remained invisible. The ground felt solid, the sky appeared steady. The stars rose and fell with predictable rhythm, repeating their slow cycles across generations. Nothing in ordinary experience suggested that the entire world was travelling through the universe. Movement belonged to animals, to wind, to water. The Earth seemed exempt. Only when the scale widened did the illusion begin to break. First, the planet was revealed to rotate. Then it was shown to orbit the Sun. Later, the Sun itself became a traveller through the Milky Way. Each discovery replaced the previous map. The ground stopped being an anchor. The solar system stopped being the centre. The galaxy stopped being the boundary. Every time the frame widened, the idea of a fixed place became harder to defend. But there is something quietly remarkable about how this motion unfolds. You are not being thrown through space by violent forces. You are not tumbling through chaos. The systems that carry you move with extraordinary smoothness. Gravity organizes their paths into stable flows that can continue for billions of years. Earth rotates with calm precision. The planet follows its orbit with quiet regularity. The Sun moves through the galaxy along a stable gravitational route shaped by the mass of billions of stars and the invisible halo of dark matter surrounding them. Even the migration of galaxies along the cosmic web unfolds slowly, guided by gravitational slopes that have existed since the early universe. The motion is immense, but it is gentle. And because it is gentle, you do not feel it. Your body experiences the motion of nearby objects that accelerate or stop suddenly, but the layered currents carrying your planet through the universe change so gradually that your senses cannot detect them. Stillness survives inside the system, but the system never stopped moving. Every moment of your life has unfolded along a cosmic path, shaped by forces acting across unimaginable distances. The atoms in your body were assembled inside ancient stars that travelled their own galactic routes long before the solar system formed. Those atoms became part of a planet that rotates through space while orbiting a migrating star. Now they continue the journey with you. The universe is not a stage on which events take place. It is a current that carries everything within it. And you have always been inside that current. Try one final experiment. Imagine that at this exact moment, the universe could leave a faint, glowing line behind every object that moves through space. Every planet would draw a line. Every star would trace a path through the galaxy. Every galaxy would leave a drifting thread across the expanding universe. Within seconds, the sky would begin to fill with these luminous trajectories. Earth would carve a tight spiral as it circles the Sun while rotating beneath you. The Sun would trace a long, sweeping arc through the Milky Way. The galaxy itself would drift along a broader curve through the local group, while the cosmic web slowly stretches around it. Now imagine the path left behind by your own body. Not just the movement of your steps across the floor, but the full trajectory of the planet that carried you, the star that carried the planet, the galaxy that carried the star. Your life would appear as a thin, glowing filament woven into a much larger pattern of motion. The line would never double back on itself. It would never return to the same coordinate. It would simply continue forward tracing the quiet journey of Earth through the solar system, the migration of the solar system through the galaxy, and the long drift of the galaxy through the cosmic web. That glowing thread would represent every moment you have lived, every conversation, every memory, every breath. All of them would lie somewhere along that path through the universe. The places you remember would appear only as short segments along the thread, where familiar surroundings happen to move with you for a while. A childhood home, a street you walked many times, a room where you once sat in silence. Each one would look like a brief cluster of moments where the same environment accompanied your journey before the universe carried it away again. The surroundings repeated. The coordinates never did. And the thread would still be extending forward into space. Because the motions that carried you here have not stopped. Earth continues rotating beneath your feet. The planet continues its orbit around the sun. The sun continues its quiet migration through the Milky Way. The galaxy continues drifting along the filaments of the cosmic web, while the universe itself expands. The journey continues whether you notice it or not. You are travelling through the largest structure that exists, and every second you move into a place that has never existed before. The room around you is quiet. Nothing seems to be moving. The floor feels steady beneath your feet. The walls appear exactly where they were a moment ago. Outside the window, the horizon holds its familiar shape. It still feels like a place. But now the map behind that feeling has changed. The ground beneath you is turning with the rotation of Earth. The planet is advancing along its orbit around the sun. The sun carries the solar system through the Milky Way, while the galaxy drifts through the local group along the great filaments of the cosmic web. All of those motions continue at this very moment. You do not feel them because everything near you shares the same movement. Stillness is only agreement. The room appears fixed because every object inside it travels together. The chair, the air, the ground, and your own body all ride the same planetary surface, while that surface is carried through larger and larger systems of motion. Break the frame wide enough and the illusion disappears. The place where this episode began no longer exists. Earth rotated away from it. The orbit carried the planet beyond it. The galaxy transported the solar system farther along its path through the universe. The coordinate vanished almost immediately. What remains is the journey. Every moment of your life unfolds along a moving path traced through rotating planets, orbiting stars, migrating galaxies, and an expanding cosmos. The places you remember were never permanent locations. They were brief alignments of moving systems. And now, as you sit here listening, the same quiet truth continues. The ground beneath you is still carrying you forward. You are already somewhere new.